Okay, we're going to do the 2014 AMC 12b, problem 17. Let P be the parabola with equation y equals x squared, and let Q be 2014. There are real numbers r and s such that the line through Q with slope m does not intersect P if and only if r is less than m is less than s. What is r plus s? Now, in this situation, when we have all of these points and curves and things like this, a good idea is to start with a visual. So we'll start drawing a graph, and we have the parabola y equals x squared, and we also have this point Q. Now, at the point x equals 20, the parabola is going to be somewhere up at 400. So this point Q is going to be under the parabola. So this is Q. And we have a line that goes through Q with some slope. We want this line to not intersect the parabola. So this is an example of a line that wouldn't intersect the parabola. If we increase the slope enough, then the line will go through the parabola. And similarly, if we decrease the slope, then the line will also go through the parabola. So we want to find all of the slopes that cause this line to not intersect the parabola. To do that, we can start out by writing an equation for the line using this point. So because we know that the line goes through 2014, we can write the line equation in point-slope form as y minus 14 equals m times x minus 20. So m is the line's slope, and when we let x equals 20, this part of the equation will disappear, which will just leave us y being equal to 14. Now we want to use this equation along with the equation y equals x squared. So we'll start out by moving the 14 to the other side, which gives us y equals m times x minus 20 plus 14. If these two curves are intersecting, then we know that this equation must be true, so that the point is on the line, but we also know that y equals x squared must be true, so that the point is on the parabola. And that means that if these equations are both true, then we can set these right sides of the equation equal to each other. So we get x squared equals m times x minus 20 plus 14. Now, in order to figure out where this equation has a solution, which would be where the curves intersect, we can move everything over to the left side of the equation and use the quadratic formula. So we have x squared, and then our x terms will be this mx. So we move this to the other side, we get minus mx. And then we have a minus 20m on this side of the equation. So we move it over to the other side, we'll get plus 20m. And then this plus 14 on the other side will be minus 14. This equals 0. So we can use the quadratic formula to solve this, which gives us x equals m plus or minus the square root of m squared minus 4 times 1 times 20m minus 14 divided by 2 times 1. Now, if these curves intersect, then we know that this equation has to have a solution, which means that these numbers that we get on the right side of the equation have to be real numbers. If the lines don't intersect, then this part of the equation has to be imaginary in some part. There has to be an imaginary part. M over 2 is always going to be real because m is a slope. So the only part that could be imaginary is this square root part. If the inside of the square root is negative, then this will be an imaginary solution, which means that the curves won't intersect. So we want the inside of the square root to be negative, which means m squared minus 4. This times 1 doesn't do anything, so we can ignore it. 20m minus 14. We want this to be less than 0, so it's negative. Now let's expand this out a little bit. So we get m squared minus 4 times 20m is 80m. And then minus 4 times minus 14 is going to be plus 56. This is less than 0. Now, in order to solve this, we know that when we have a quadratic equation, we can always write this quadratic equation in terms of its roots like this, m minus r1 times m minus r2 when the coefficient of m squared is 1. And when we write it like this, we can use this part in order to determine when the inequality is true, because if we know that this is less than 0, then we need one part to be positive and one part to be negative. So if we use the quadratic formula to find the solutions of this as an equation instead of an inequality, we can use those as the roots to factor our equation and figure out how to deal with this inequality. So let's go over here and use the quadratic formula, which will give us m is equal to 80 plus or minus the square root of 80 squared minus 4 times 1 times 56 divided by 2 times 1. Now, in order to deal with this, we have 80 over 2 first, which is just 40, and then we have this square root. Now if you try to expand the square root and figure out what it equals, you'll figure out that it's not an integer, and it's really ugly to deal with. So what we're going to do is take this square root of all this stuff divided by 2, and we're going to let it equal a. So we can go through all of our calculations just letting this be equal to a, and then we can deal with it later. So we have m is equal to 40 plus or minus a. That means we can go over to this equation again, and instead of r1 and r2, we can write this as m minus 40 plus a times m minus 40 minus a. And this is less than 0. So this is an equation that we can use a lot better. Now, when we look at this equation, we need to have one of these parts being positive and one part negative for this to be less than 0. Now, because a is a square root, we know that a is positive, which means that when we do minus minus a, that's going to be the same as plus a plus a positive number. And on this part, we have a minus a, which will be negative. And because of that, we know that this part with the plus a is always going to be greater than this part with the minus a. So if this part is negative and it's greater than this part, then this part will also be negative. So if this part's negative, this part will be negative as well. That means that this part can't be negative for this to be less than 0. So this part has to be positive and this part has to be negative. So we can write that information. If we want this to be positive, then we have m minus 40 minus a has to be greater than 0. And the other part, we have m minus 40 plus a. This has to be negative, so we get less than 0. Now we can solve both of these equations. This part over here, we get m is greater than 40 minus a. And this part, we get m is less than 40 plus a. Now we can write this part as 40 minus a is less than m, just switching these around. And if this is true, then we can use this information for this part of the inequality to put here 40 minus a. And now we have 40 minus a is less than m is less than 40 plus a. And this is all the times where the lines do not intersect because this equation has no solution. The square root's negative. This is in the same form as this part here, r is less than m is less than s, which means that this part has to be r and this part has to be s. So in order to find r plus s, we just have to take 40 minus a and add 40 plus a. So if we do that here, 40 minus a plus 40 plus a, the minus a and the plus a are going to cancel, which means we don't actually have to calculate this square root at all. And that just leaves us with 80. And that is r plus s. That is our solution.